Welcome to Constructor Talks, where we go deep on anything and everything at Constructor University. My name is Scott Peterson, Head of Communications at the university here. Today, we're going to be talking about space. While perhaps the final frontier, it's no longer untamable or a far-fetched idea. The Lunar Gateway, for example, is set for launch in 2027. Spaceflight is a vacation destination for some, and there is a certain high-profile CEO out there who would have you believe that, shout out to David Bowie, life on Mars could be achieved by 2050. If, and it's a big if, those plans are going to come to fruition and a Martian colonization, as it were, is going to sustainably take hold, we'll need manufacturing and production capabilities on site. Joining me today to discuss 3D printing in outer space, among many other things, is Professor of Logistics at Constructor University, Chair of the school's Supply Chain Management Program, Research Affiliate at MIT, and entrepreneur, Dr. Yilmaz Uygun. Welcome to the podcast.
Yeah, thanks for having me.
Absolutely. As I alluded to, you are a man of many hats, and we're going to get to outer space and all that in a minute, but I'd like to start with you and kind of where your interest came from in engineering and research, and what kind of drove you to pursue a career in academia.
Yeah, to be honest, actually, my interest in engineering originated in, breaking things and fixing them and then figuring out that actually you can classify it as research.
Okay, a self-fulfilling prophecy then, so to speak.
Right.
All right.
But it's here in Germany, you're really exposed to engineering, right?
Mm-hmm.
So therefore, engineering is everywhere. And so therefore, I was also deeply interested in that and wanted to explore more. What it is.
So it started kind of at a very early age of just noodling around and tooling with things.
Correct. Yes.
Okay.
Yeah.
And what did you start out studying then at first?
I started off with industrial engineering with a European focus. So we actually dealt also with a lot of topics around the European Union. We also went to Brussels and so on. But the interface between engineering and management was really exciting. On the one hand, it's actually really great to work on technologies, but on the other hand, it's really important to make money with that, right?
Sure.
And how to organize things, right? Because when we talk about companies, where you want to end up doing stuff, we're talking about socio-technical systems, right? So we have actually people, we have technology, and those need to be organized. And so therefore, this interface and this challenge was really appealing.
So finding use cases that were feasible beyond the spheres of academia, essentially.
Correct. It's actually, really exciting because it's a very application-oriented field. And so therefore, the application side of this is really interesting. So to apply it and then to make it available for the broader audience, so to speak, or for, the broader public, to make things happen and also contribute to, the further development of the society and technology. So that's really important to apply and transfer this knowledge.
Okay. And then how did that lead you into 3D printing or additive manufacturing, as it were?
It was actually always a topic. In the 2000s, a lot of patents expired around 3D printing, and then, the hype started with 3D printing and so on. And I was one of the earliest, let's say, enthusiasts, and then I delved deeper into this topic, and at some point, one thing, came to the other, it added up, and at some point, I ended up doing 3D printing here at this university, at Constructor University, and we ended up building one of the largest 3D printers. And that was a real eye-opener to understand, 3D printing better, not just applying it, but also to understand what's behind that.
Okay, so there was these patents are expiring in the 2000s, and so basically it kind of created this gold rush mentality, or people had access, this open source of all the original, I guess, patents for the printers themselves, correct?
Correct, yes.
Yeah, and then you were able to kind of tap into this, just basically this treasure trove of previous knowledge and prototypes and all this stuff that you could kind of apply to your own studies. And this is something you did here at the university? Like this program was pre-existing?
Yeah, I did it also in the States. So there was also a huge interest, especially in applying 3D printing in aerospace. But here at the university, I had done the freedom, so to speak, the academic freedom, to look more into this topic. I could also find some funding bodies that would also fund then our research here. And one thing led to the other. So then, it evolved. So we, as mentioned, developed, an own printer here, but it also was really interesting to industry. So companies approached us to print stuff on this, and this gave us the idea to actually explore this more in terms of, making a business out of that.
So that's interesting. So some businesses from around here, so we're in Bremen, Germany, around the area, or maybe in Germany or Europe, reached out to you because they found out you had your own printer and wanted specific business use cases in products. They reached out to you for that.
Correct. So this is because our printer is actually pretty big, and there are not so many big printers out there. And so the normal desktop ones, so let's call them desktop ones, the smaller ones, you are limited in size, all right? And then there are companies here that look for larger parts, right? And then there is nothing like that around. And thanks also to the university PR department here, we could reach out to those companies, and then they knocked on our doors, and then we sat down, and then we developed, some of those, and printed some of those big parts. That's actually our USP, so to speak, printing big parts, and we're mainly alone in this field.
Good place to be.
Yeah. Right.
So what size are we talking about? Like, so you just alluded to the fact that you can print and produce abnormally large parts.
Correct. So it's actually, so we have a Delta printer. So we have a diameter of up to 1.8 meters and a height of up to 2.2 meters.
Okay.
And we were actually limited by the size of the lab, right? Otherwise, we could have gone even bigger.
Okay. Is the lab transferable in that sense? Or like, could you possibly build another printer if you had a larger space then?
Correct, yes.
Okay.
So currently we are in discussions with them, with the university. And that's the idea actually because we also wanted to print, it's actually not just, we do this because we are capable of doing it. It's actually more, we have other projects going on where we need large parts, and that's the idea. So the larger, the better. So and now we have a project where we need to print, or we need to have large parts where that we cannot actually get on the market in an affordable way. Let's say, right? So it's so therefore we need to do it on a printer because we are currently further developing, the products, and for that, it's better to have, this kind of flexible approach to it.
Well, we've been talking already a lot about some of the applications of a 3D printer. Can we talk maybe then back up a little bit? Like, what exactly is 3D printing in simple terms as it compares to kind of more traditional forms of printing or manufacturing?
Yeah, maybe 3D printing is similar to human habits. You build something layer by layer, right? Like like bad habits, right?
Yeah, fair enough.
But the thing is, it is, so there are different techniques for that. But in general, we can say it's, so you have an input material. It could be plastics, it could be metals. So you melt this. So normally it's solid, or it's in powder form, or even liquid is possible. And maybe let's stick to the powder and the solid input material. So you heat it up, right? And then you squeeze it out of the nozzle, so to speak. So layer by layer, like squeezing a ketchup bottle, so to speak.
And you basically give the machine then kind of a file or a design to follow exactly this. And so there's a lot of moving parts, and you have a team, I would imagine, students and probably some colleagues as well. So maybe walk me through, pretend like I'm a customer from here in a client from here in the Bremen region. I have like a bespoke need, a very specific need.
Correct.
how do we go about turning this idea or this need into a finished product?
Yeah, of course. Yeah, sure. So it's first and foremost, we need actually the 3D drawing, so the technical, so the engineering drawing, so to speak, so which is mainly done maybe in software like AutoCAD, and then we get these files, so we can play around, and then we can optimize the product. And we get it, and then we throw it in a slicer, a so-called slicer software, where then you can define the number of layers, the thickness of layers, and the speed, everything, right? And then the code is being generated, which is then machine readable. Right. So
Okay.
therefore, we send then that code to the machine, where then the machine drives. It depends on what kind of 3D printer you have, but with our Delta 3D printer, we have 3 motors. So we have 3 arms that are individually operated by a motor, and it can individually be moved by a motor. And then we send the codes to this so that the motor can actually move in a direction to reach any part of the surface to start printing it.
Okay. And so what are like some of the specific use cases, some of the parts that you've actually created for some of these companies around here?
So it's as diverse as automotive, engineering, wind, and even marine industry, where first we started off with prototypes, where companies wanted to see actually prototypes of their products, also of large sizes, right? On the other hand, we have another project with wind turbines. So we built 2 meter, 3 meter, and 4 meter turbines. And we printed them here on our printers, and these are just some examples, and also some parts for the automotive industry. For an engineering company, they wanted to have some kind of engine block to calibrate their machines with, right? So different, very diverse, and that's actually also the power of 3D printing. That you can build any product you want, as long as you can actually design it in a software, as mentioned, like AutoCAD or so. Then you go and then you print it, and then you can play around with that.
There's no limitations as long as you have the design.
Correct. Yes.
Okay. Well, then what are some of the let's just say so you the troubleshooting, or the things that can go wrong, or the things that you have to actually test for? So you are making a prototype, but you're not producing in serial production. Is that correct?
Yeah. But
Yeah.
there are also some initiatives that are using 3D printers in final production, but it's not in series production. So it's actually because it takes time. So they are not that fast. That's actually also not their strength, so to speak. But yeah, they're also being used in.
Okay, but like the main thing is like you can produce a prototype for basically any design, and then you can see whether or not like it can be feasible for a traditional method of production. So it's actually transferable then in that regard.
Yeah, sure. And it's also really, so besides actually prototyping, you can also have final products with it. It depends actually on how accurate and how which kind of material, for example, you use for as your material. You can also develop. You can also have final products, but the thing is more one-off products, or let's say small batches. And that would be also it's also possible.
Okay. Then so when it comes to then these end products that you were producing, are there any shortcomings in the materials that you're using compared to certain let's just say titanium alloys or something when it comes to turbines, or just traditional materials, or is the drop off negligible?
No, it's actually there. It depends. So there are several challenges because you build it layer by layer. Normally, it's actually you can rip it off easily, right? If you just actually, so then there are other techniques where you can actually strengthen, the surface and the material and the part that you print. And on the other hand, it heavily depends on the material that you use, right? So it's Normally, plastics, so the standard plastics like PLA or PET and so on, they are really good for prototyping because they're cheap, or so rather cheap. But they're also very high performance plastics, which melt at, I don't know, 300, 400 degrees or more.
Okay.
Normally, the other ones, they melt, way below this range. But they're pretty expensive.
Okay.
Right? So it depends on also the use case. And metals is the same, right? It's also not that cheap, so to speak. But the good thing is, if you don't have a post-processing in terms of maybe coding or something like that, if you have the pure material, then in many cases, you can reuse the material. You can actually have a shredder, for example, and then you can use it. If you have a pellet extruder, for example, you can put it in there, and then you can use it over and over again. So, which is also a sustainable way of doing it.
Okay, well, that's very interesting. So then, why? What makes this type of 3D additive manufacturing, what makes that kind of suitable for then extreme environments? So like space, and you mentioned like 300 degrees as the melting point. I would imagine that at least there's got to be some drawbacks and some limitations there. And so just maybe walk me through the advantage of having a 3D printer in these extreme environments.
Yeah, on the one hand, it's actually, when we're talking about space, it's the weights, right? So you have payload, right? It's actually, if we want to build colonies on the moon, Mars, and beyond, we need to think about the infrastructure, right? And then earthbound supply at some point would be very expensive. And the best would be to use raw material that is always there, regolith and so on. There are some companies out there that are doing, these kind of, mining, so even asteroid mining and so on. And that would be a major breakthrough. So then you would have actually this compact 3D printer there, and then you can print it on demand without actually, and even think of large parts, right? So it's really hard to put this. So you need to fold them at some point, but some parts should not be folded and so on, or inflated. And then you need to put it in a rocket, and then you shoot it up to the moon. So, and doing it over and over hundreds of times in order to build maybe a habitat there, that would be maybe not very feasible, right? From money perspective.
Sure. Definitely not very sustainable. You would you wouldn't think. But then, so you have this maximum flexibility, like once you actually have the raw materials up there that you can use, and once you have the printer in place. Maybe you can discuss a little bit about Nebulaform and how that kind of ties into this vision of putting a printer up in space, and walk me through some of the logistics of getting that printer up there.
Yeah, so it's actually a very interesting, and I would say it's a very nice success story that came out of my research group here at the university. So as mentioned, so we got funding for our research activities in 3D printing, and it led then to a startup funding by the federal ministry. Then finally, we got accepted to the incubator of the European Space Agency. And on this way towards, this incubator, we adjust it, because the thing is, you need to put an ear to the ground and then see what is actually necessary, just to actually developing something for the sake of developing it, right? It's not very helpful. So it's good, maybe as a scientist, it's really nice to test, the limits of technology, something like that. But as mentioned, I am in a very application-oriented field, and I always, look beyond, research and development, because this should also have a real-world impact. And so therefore, we always were guided by those customer requirements. So on the one hand, the discussed companies from engineering, manufacturing, automotive, and so on. But on the other hand, here in Bremen, we have a really great ecosystem of space and space technologies. And so here as well, one thing led to the other, and then we came up with this idea to say, okay, look here, we also need 3D printing for space and in space, right?
Mm-hmm.
And that was the starting point of this endeavor. And then this company came to existence, so called Nebulaform.
Mm-hmm.
And currently we developed a concept of a foldable, 3D foldable and moving, so self-organizing 3D printer that can be used, that can be actually put in a rocket and can then easily be brought to the moon, for example, where then it actually then unfolds and can
By
be
itself?
used.
Or like
That's the concept. So
you put a printer, you fold it up, and then
correct.
okay, I'm obviously not an engineer, but then you would get it up onto the moon or Mars. You press a button, and then it would basically set itself up.
Correct. That's the idea, and it should also be movable, like a Mars rover, right? So
Yeah.
those and so on. So we developed those different concepts for that, and currently we are working on the feasibility of this. So we will first test this here in remote places on Earth, like in extreme places, like desert-like areas and so on, to check if also, for example, the energy modules work properly. So solar-based energy modules and so on. And that would be also a real thing for terrestrial applications, right?
But maybe you can also there's also some challenges that are going to be really hard to either recreate here on Earth, some conditions. So, okay, you can have the desert-like conditions of outer space beyond the atmosphere, outside of whatever man-made habitats we create. But then you have the exact opposite conditions if you have zero gravity, like in water. And those are like two completely different habitats and different challenges to address. So how do you kind of go about troubleshooting both of those at the same time?
Yeah, especially, we were focusing mainly on the moon. So there we have some kind of gravity, right? But the thing is, using especially the printing technique of fused filament fabrication or fused deposition modeling, it's not a big thing because it's actually squeezing out, the molten material out of the nozzle. So therefore, that would be not a challenging thing, and that doesn't require, that much of, it's not very. It can also work, in low gravity.
Okay.
So, and the idea of testing it here in let's say in remote places is from a business perspective also important because the thing with the space missions and so on. So we're also in discussions with some national space agencies to test a smaller version, a scaled version of our printer because of the payload, right? It's pretty expensive in outer space. And the thing is, it's still a long shot, for the whole thing with humans on the moon, on Mars, and so on, right? But if you want to make money, which is the ultimate goal of any business, right? So we need to find also business cases here on Earth. And this was also an interesting case where some institutions approached us and said that would be also interesting for us, right? So so we are currently, exploring these opportunities, and we're looking forward, to where it takes us.
Sure.
Yeah.
So you mentioned that you wanted that there's at least discussions ongoing about sending up a prototype, a smaller scaled down version of the printer to outer space. Then you also mentioned how the printer that we have here on campus its USP is the size and the scale of what it can actually produce. What type of parts are we talking about right now with the potential prototype that is going to be sent to outer space? Like what would that be for? Is this more spare parts type of things? And what is kind of the use case then in the grand scheme of things? Like if everything
Yeah. So actually, the the sky is the limit, right? So
Right.
it's the maybe not maybe I would say it's beyond the limit, so to speak. It's the sky is not the limit. We have to say actually, right?
It's the
Because,
wrong metaphor.
yeah, we are actually talking about outer space, right?
Mhm.
So the thing is, yeah. So first and foremost for us, so I have two hats, right? So on the one hand, scientist, and on the other hand, also an entrepreneur. Uh, I'm really, on the one hand, really interested in exploring the feasibility of this.
Mhm.
So even with a scaled model. And then, right, we can talk about possible business cases, business models with that. But first and foremost, we need to make sure that it's actually working, that we can really print stuff with this.
Mhm.
And as mentioned, so there is no limit to what you can print with this. And 3D printers are really good if you have more complex products because
Mhm.
so simple products, flat, so simple geometries, right? Maybe that can be done, but maybe 3D printer would be not the first choice, if you want to do, those simple geometries. But if you have more complex geometries, right, where you can print stuff which makes additional assembly steps, for example, redundant. That's
Okay.
where 3D printer is really helpful and useful.
Okay. Well, then you mentioned that you have many hats. So you have two hats, entrepreneur and academic. You have a team here that's also kind of a combination of that, correct?
Yes.
So you have some research students here,
Mhm.
and how that kind of ties into itself, and how they both kind of, rub each other's, grease each other's palms, as it were. So maybe when you are teaching and when you're active as an entrepreneur, where do you see kind of like the overlap, and where is the difference? I mean, obviously you have more of the profit motive when you're an entrepreneur, I would say, and like you're thinking in terms of, it's a business, it needs to be profitable, you need to make money, or at least see that use case, that potential. Um, is there an overlap between those two hats, or is that what's kind of makes them appealing to you?
Yeah, for sure. I would say actually, teaching. So you teach actually state of the art technologies, and you show how things work or should work. And
Hmm.
then actually, if you are an entrepreneur, then most of the cases, then you'll see why. So you're at some point desperate to understand why this is not working,
Hmm.
right, as it was intended, or you've learned in books, or in class. The thing is, yeah, it is teaching. At some point, you have to. So you learn from things out there, from nature, and from doing stuff, experimenting, and so on, and you try to generalize it. So you not try to develop some generalizable things, let's say theorems or theories. But if you then are in application, if you then are doing stuff and want to actually develop stuff and sell it, right?
Hmm.
Um, it's a unique situation. So you face unique challenges where then, the stuff which are the basics need to be, amended or need to be further developed, right?
Yeah, and
So that's
specified.
yeah,
Yeah.
that's and then customized, for example, right?
Okay.
And that's actually, so you have a solid foundation here in teaching, and then it in out there in industry. So you need to customize it and apply it to your situation,
So basically,
adjust it to your situation.
right. So you view your role, excuse me, you view your role as somebody who's providing like a framework
Yeah,
within like for students to kind of think within, and then once they actually start applying it, then they need to fine tune it and actually really tweak this framework or customize it, like you said. Do you kind of see yourself as a mentor, or see like you need view your role as, and like part of your obligation is to kind of foster like this type of entrepreneurial mindset?
absolutely, absolutely. So it's just, yesterday we went to a very research-oriented institute here in Germany. And I also worked in the States, and there I could see actually the difference, the different approaches here and there.
Hmm.
And for sure, I want to help students not to think, in those frameworks, but actually, giving them a solid basis where then they can actually look beyond and then think out of the box, right? In order to solve problems, because we face problems every day, and especially if you are an engineer, you try to solve problems. So you see a problem. Where others don't see them, for example, right? And then you try to fix it, right? So that's in our DNA as an engineer. So you try to fix, all the problems. And here in Germany, we develop really great technology, right? And unfortunately, the entrepreneurial spirit, as we can, the one that we can see in the States, for example, is not. Is not comparable to the German approach. So therefore, I see this, and I'm really. I find it sad to see that those nice technologies, nice proof of concepts, and so on, are not been brought to practice, because the approach here is you need to find a company that buys this idea, right, and then develops it within their institutional resources. Whereas in the States you have this the startup culture, you have the venture capital culture, and so on. If you have a nice idea coming from universities, and here we also have a lot of nice ideas, you can easily find a financial sponsor for that. Right?
So you think the majority of the really good technological ideas in Germany kind of fail because they are unable to find funding?
On the one hand, yes. On the other hand, it's actually I would say, not the missing, but the entrepreneurial spirit that is not comparable to the one in the States.
Thinking too much like a scientist as opposed to a businessman.
Okay. And it's more about that. Yeah, you're right. For example, also a very interesting example would be the MP3 format, right? It was developed here in Germany by the Fraunhofer Institute, right? And so in the mid-90s, but it took off only after, Apple introduced, the iPod. Right? So up to that moment, it was just actually a very interesting and nice technology, right, to compress files and music files and so on. But thanks to another company, right, it took off. So that's maybe we can do better here. So to also. I would call this, the valley of death, right? So we develop prototypes up to a demonstrator or a prototype or a proof of concept, right? And then that valley of death is actually to bring it to existence, right? So it's and then to make money with that, right? And there you need help, all right? And you need to have this entrepreneurial spirit, right? So we need to train students, and we need to open their eyes and hearts for entrepreneurial endeavors. And this is also what I try to do. Also by so we have right now 3 startups, I would say, from my research group. So, but these are mainly. These were initiated mainly by the PhDs, right? But also we have several students that have really great ideas, and they also and we have even more, but maybe they do not come forward with the ideas because they don't know how to approach and how to develop the idea and how to find their place in this ecosystem and so on. So therefore, I try to also show them with our own examples. It's possible, and these are the different approaches. So VCs have this kind of approach. If you want to go to angel investors, maybe crowdfunding, and what are the differences and what are the pros and cons. But in any case, stick to your idea if you really believe in this. And if there's a business case, then go for it.
How's the university kind of helped you, or like maybe kind of helped at least support the idea? Because I know like we have the academic side of things going on here at the university, but Constructor University is part of a broader group. has angel investing, has access to capital funding, and also there are some successful startups that are also tied into the group. Does that kind of being a part of that ecosystem, does that lend itself, like lend in terms of credibility, or just like the not trying to kind of stamp on that entrepreneurial spirit that and to help you survive the valley of death?
Yeah. Yeah, for sure. It's actually it's a great ecosystem that we have here. So the constructor ecosystem, I would say, because we see that even the Constructor Capital, so that the VC fund of the group is helping, is investing in ideas. It has a clear focus on information technology in the broad sense, I would say. But also the ecosystem here in the region, right? So we are a small state in Germany, and there's also awareness for fostering startup culture here. And we have still a lot of holes in the innovation ecosystem here and the startup ecosystem here in Bremen and the region, also across Germany. But they are addressing it. So one big problem that I see is, funding. Because startup and so on is all about money, right? So if you're an entrepreneur, your main task would be, finding money for your idea and then make it, and then also developing your product to a point where you can start selling it, right? So then you need this upfront investment, and then you need a lot of investment to build up a team and everything. So it's actually all about finding or putting together a budget, right?
Sure.
And so I would say we also have, all those different activities here on campus, and that helps a lot. And we also try to help students with our 3D printers, for example, if they have a product-based idea, right? To offer them our capabilities here to develop or to print, to produce a prototype. And that's, I think, a nice environment here at the university. We also benefited from that because the university gave us the freedom, to do the research, and also thanks to the supporters, the financial supporters, we could develop our products up to a point, up to a certain stage in this innovation cycle, so to speak, where we could then start a business.
Sure, and start to kind of monetize some of these ideas, or at least to like provide the...
We're still working on it.
Right, start working on it, but at least providing like the people who are actually going to be supporting it, financing the projects up until they get to that point, are going to see the kind of like the plan for success, at least in some timeline. I'm just curious, so like we have this university here, which is an English-speaking university, also highly international. So you have a very large talent pool to kind of draw on. And you mentioned like some of the differences in mentalities from the US entrepreneurial mindset to the engineering focus here. I imagine that is somewhat challenging to try to get through to like some different cultures to a degree, but I imagine that is just a huge boon to be able to draw on this like very kind of diverse talent pool. Right?
Absolutely. Yeah, absolutely. It's great to have so many different mentalities, so many different also views on things. So each student, so when we discuss, for example, problems, they come up with different approaches. And at some point it is that makes the discussion really vivid. So in class, for example, but also in our research group, I see that they really smart PhDs that I'm really happy to work with them. And they really come up with great solutions always. And I'm really surprised, and I'm really happy to have them. And also this diversity. And that's an enriching experience. Which helped me a lot, and which is, I think, so one example would be, one of my research associates, he is, he comes from a culture where, you directly, so you don't think that much about, the outcome, right? You just start, right? Whereas here in Germany, we love overthinking things, right?
True.
And that's, what I learned from him, that actually, okay, that's at some point, okay, just start, just do it, right? And then we'll see. But they
the
should be,
idea doesn't have to be perfect to start
correct.
on it, right?
Yes, yes.
There's going to be
Especially,
problems anyway.
especially when we talk about R&D, innovation, and so on.
Mhm.
Just do it, right? And otherwise, it all, you start and you kill the idea in your head, because of this overthinking.
Right, exactly. You have this like this internal kind of like a governor on your own thoughts, or like just like you just forget it, like it's never going to work. So why even start?
Correct.
So as somebody who's pivoted from kind of the academic into the entrepreneurial sphere and ecosystem, since you're still involved as a professor, what are some of kind of the skills and some of the lessons that you're trying to impart on your students as it pertains to becoming an entrepreneur, or like taking some of these ideas that they have and actually making something out of them?
Yeah, it's the first thing is actually curiosity. All right, so they need to stay curious. So they need to actually always be open for new ideas, and then should see always opportunities in challenges, and not actually they should not break out in tears when they face challenges or rock bottom. And also we try to teach them the problem solving skills, right? So these are the tools, you see this, and then you should embrace, this problem, and then you should then attack this and tackle this and then find a solution for this. And the moment you find a solution, then it will actually you will grow with this problem. And then at some point, if you see, okay, this is a problem that so I'm not the only one dealing with it, so then you can think of beyond your studies and so on. You can think of starting trying to monetize, make money with that problem solving.
Okay.
So the problem solving skills are really important. Curiosity, and at some point, they, especially for our students here, they also need a good overview of the innovation ecosystem here, because we talked about the financial things. This is of utmost importance, right? But also support. There are a lot of institutions out there that help them, so incubators, accelerators, and so on, right? Networking events and so on, which is really helpful.
Okay. So you'd mentioned tears and how crying doesn't necessarily help you in the long run, but I am curious, failure tends to help you, and it kind of tends to lend itself to success. I'm curious, how do you feel about that statement? Like, to what extent does failure actually play into success?
Absolutely. So it's actually, you learn a lot from failures. So it's I would say you wouldn't learn that much if you have a tutorial, right, with a 10-step approach.
Where somebody else is doing the thing for you.
And then you're just actually replicating it and so on. So you wouldn't learn that much. But if you then face these kind of problems, and then the machinery starts working, right? And then you try to understand, what's going on. Why did it fail? And then what can I do? And then how can I actually solve this? It's great if you are in R&D, for example. Then you should face these problems in order to understand the limits of this technology, for example. And it would cause less harm, right? But if you are in commercialization, right? If you have a company, if you have a product, and then if you face, we have different kinds of problems, but if you face some essential problem, it could, break your neck at some point, right? So, at some point, yes, failure is important.
But learning from the mistakes, I think, is even more important.
Yeah, absolutely. Yeah.
Then just to like kind of put a bow on this conversation, which has been fantastic. I can't believe the time has already gone this far. It does indeed fly. But how would you define success for you, for yourself as an academic, as an entrepreneur, and maybe specifically to Nebulaform? How do you approach that question? If you were going to try to answer, what is success to you?
Yeah, I think success is for me personally always learning and always learning more, right? So the moment when I look back and then say, look where I was last year and where I am now, and then I learned that much, right? Really useful things, right? And then we actually here at the university, we always teach useful things, right? So therefore, that would be actually, I think, a measure of success that students say after 1 to 3 years, that they say, now I actually am packed with this useful knowledge, and this is important. It's a success that they graduate and then that they can enter. So this learning curve, I would say that would define my success. It's not actually money. I wouldn't say that. Money should not be actually an ultimate goal. At some point, you also, so money is just an enabler, right? Enabler to learn more and then to grow your brain, so to speak.
Yilmaz Uygun, thank you so much for taking the time and joining me.
Yeah, it was great. Yeah, thanks for this nice talk.
My pleasure.